Okay, so now we're going to start talking about the rocks that are made up of minerals. So this is target 37 and 38. Be able to classify the three types of rocks based on how they form and other characteristics, and relate the rock cycle to the theory of conservation of matter. Now this is a review, okay, from 6th grade. We did rocks in the rock cycle, so this should be a review before we start our asteroid impact project. Okay, so remember, an igneous rock is a type of rock that forms from the cooling and hardening of magma or lava. So if we take a look at this picture, we've got magma. When it rises and comes up through a volcano, you've got lava that cools and hardens and forms a volcanic igneous rock. Okay, if it forms from magma, it can be a plutonic igneous rock. Usually a lot of your igneous rocks are made up of the metals zinc elements, zinc, copper, iron, and gold. I don't know why I have that picture in there. Okay, there are types of igneous rocks. There's extrusive igneous rocks. These are what form from outside the Earth's surface. They cool quickly. And this extrusive rocks are from lava, usually from volcanic eruptions. So when lava erupts, it's exposed to air and sometimes water, so it cools really quickly. So remember from when our minerals, when something cools really quickly, then it doesn't have time to grow large crystals. So you have small crystals, we call those fine-grained. And sometimes extrusive rocks, if they're exposed to water, if that lava hits water like an ocean in the Hawaiian Islands, you'll see holes in the rock from the water evaporating. So that's an example of an extrusive rock. Intrusive rock, do I have any other pictures? No, okay. Intrusive rocks form inside the earth. So they have, intrusive rocks have, are exposed to a lot of temperature and they have time to form, so they cool slowly. And they have large crystals, which we call coarse grain. Granite and basalt are the two most common intrusive igneous rocks that we have here on Earth. Granite, you will actually find, makes up most of our continental crust. Basalt makes up most of our oceanic crust. So those are the two types of igneous rocks forming from the cooling hardening of magma and lava. Our next type of rock is sedimentary rock, like sandstone and limestone. Now, let me move that smaller. Okay, there we go. Now remember, sedimentary rocks forms from other types of rocks. So sedimentary rocks form from either igneous or are metamorphic. And I forgot to mention, remember, igneous rocks are what all rocks start out as. Okay, so sedimentary rocks form from other rocks through weathering, which is the breakdown of rock into small pieces. Those are called sediments. Weathering can be done by wind, water, and gravity. So weathering, water hits this rock, breaks it up into sediments. That's what that picture is right there. There's no back button. There it is. And then erosion, remember, is the movement of those sediments, which can be caused by the forces from wind, water, and gravity as well. Deposition is putting down that sediment. So we're dropping it somewhere. Compaction and cementation. Sediments are pressed together, sometimes form layers, and then you have your sedimentary rock. So here we go. Weathering and erosion, breaking down sediments, moving those sediments. They get moved, they get deposited. Those sediments get deposited over time. Then they get compacted or buried, and that can form a sedimentary rock. Okay, these are some examples of sedimentary rock. Okay, this is just another diagram, okay, showing you sediments, compaction of sediments into a sedimentary rock. And a lot of times your sedimentary rocks contain fossils, because when living things die, their remains will fall to the ground, and then they will get buried under sediments. And over time, those sediments can be compressed together containing fossils. So a lot of our record for the geological time comes from fossils found in sedimentary rock. Sedimentary rocks can also form from solutions. When water evaporates out of solutions, it can leave behind a sedimentary rock. This happens a lot of times in caves. That's what you see being left behind when the water evaporates, calcium carbonate, which forms a rock. Pretty cool stuff. Okay, and the last type of rock are your metamorphic rocks. And I gotta make that smaller because for some reason I made it too big. Okay, so metamorphic rock is an already existing rock as well. And basically you take either an igneous or sedimentary rock and you apply heat and pressure to that rock, and that causes it to change. That's what metamorphosis means, to change. This happens a lot near plate boundaries. You see rocks that are getting subducted or uplifted, they get exposed to heat and pressure, and they change into a metamorphic rock. For example, continental crust that gets subducted, the granite can turn into gneiss, which is the metamorphic rock. Shale is a sedimentary rock that can turn to slate. Sandstone, a sedimentary rock that turns to quartzite. Limestone, a sedimentary rock that turns to marble. So we find a lot of our metamorphic rock near plate boundaries where subduction is occurring. Okay, and that's just showing you a picture of pressure, faulting, when we have faulting, where our plates are colliding in certain ways and we have those forces of tension and compression and shearing, that can also cause a rock to change. And you usually get what we see here as bands. You guys see these different bands? So that means that the minerals that made up the either igneous or sedimentary rock, they get smushed, and they don't form perfect layers like usually in sedimentary rocks, but they get bent and you see waves, and we call that foldation. So a lot of times your metamorphic rocks have waves in it, and you can see those actual crystal and mineral waves due to the stress that they've been put under. Okay, so again, showing metamorphic rock near plate boundaries. These are the bands that I was talking about that occur when you have pressure being put on that rock. Okay, and the last thing we want to talk about is the rock cycle. So rocks can be weathered, eroded, compacted, cemented. They can be heat and pressurized and melted. But that rock material, all those elements and compounds that make up that rock, that make up that mixture, is not destroyed or created, it's only changed. That's our theory of conservation of matter. Matter cannot be created or destroyed, it can only be changed. So the rock cycle is an excellent example of the theory of conservation of matter. So if we take a look at the rock cycle, this one rock, this igneous rock, things can happen to that rock. It can be changed in many ways, but we're not creating or destroying the matter that's in the rock. We're just changing it. Did you love that one with little bones for fossils? So cute. Even when a rock gets melted, you're not destroying the rock. It's just going from a solid rock to a liquid rock, and that liquid rock is magma. Okay, so hopefully after these notes you've got, this should be a review of your different types of rocks in the rock cycle, tying it to the theory of conservation of matter. Okay, now what you're going to do is you're going to start the engineering project, and it's called Asteroid Impact. Okay, that picture is a little big, but Asteroid Impact. All right, so here's how our project starts out. Okay, we've got what's called a situation critical. Okay, this message is to the U.S. Special Engineering Task Force on Catastrophic Collisions. It's you guys. This message is from the President of the United States of America, Mr. Homo de Brave. The subject, immediate deployment of special engineering forces for situation critical asteroid impact. Code name for this situation is big rock. Clearance code to get into the room, you have to say, run for your lives. The date, 0600 hours yesterday. Okay, National Security Advisor, okay, Mrs. I Keep You Safe, that would be Mrs. Donaldson, our principal. The Director of Asteroid Research, Mrs. Icy Stars, that would be also known as Mrs. Stevens. So you're more than welcome to call Mrs. Donaldson by Mrs. I Keep You Safe, and you can call me by Mrs. Icy Stars during this unit, during this project. Okay, so let's look at the project. Ladies and gentlemen, on behalf of the American people, I hereby call you to action to address a serious matter of national security. An asteroid with a 1.6 kilometer or 1 mile diameter is headed straight for Earth. NASA does not know its exact impact location. However, they do believe it will impact somewhere in North America. NASA scientists project that the asteroid will impact Earth in approximately 13 months. Time is critical. You have 2 weeks to design a solution. Scientists and engineers have modeled the asteroid impact and expect it will produce an enormous crater, even bigger than the Barringer crater in Arizona, shown in this picture. The crater is 2.4 miles deep and 1 mile wide. The immediate area around the impact location will experience severe damage. In addition, a dust cloud will form and produce a worldwide winter for a year or more. All humans will need to be sheltered below ground. I'm tasking you with this ultimate assignment. Design a system of underground caverns to house people and necessary supplies to save the people of Alabraska until the pending natural disaster has passed. As engineers, I know you are well qualified and you will use science, math, and common sense to save millions of people at risk. In addition, rock samples and detailed maps of the state of Alabraska have been sent to you. So the maps that you will be looking at, okay, this is a general map of the map of Alabraska. It gives you information about roads, cities, airports, water, gives you elevation information, fault lines, where fault lines are located. You will also be given a geological map, so you'll be learning or using what you know about rocks to design where you're going to dig and build an underground system of caverns. You've seen the key. I've given you all these names of the different types of rocks. You'll have to look those up and classify those as igneous, sedimentary, or metamorphic, and determine based on their properties, their hardness, their color, their luster, their density, their streak. You're going to have to determine which rock would be the best place to build your caverns to save the people of Alabraska. So you will be given these tools in class to help you address the situation. This information will also be on my website under the video for you to look over the letter again that I just read to you. These maps will also be attached as well. So hopefully you will be using what you have learned in targets 36, 37, and 38 to help you address this problem. Good luck.